Welcome to Hartman Math. Before we get to our lesson on systems of inequalities, a little warm-up review of other concepts from Chapter 7. Go ahead and pause here until you've worked out problems 1 and 2. All right, number 1, our partial fraction decomposition. Remember, we want to factor the denominator. And then our unknown numerators of a and b. We want to add those fractions together, focus on the numerator. This one's missing the x plus 4, multiply top and bottom. This one's missing the x minus 1, multiply top and bottom. So our numerator is a times the missing factor plus b times its missing factor. And that will equal this numerator over here. So in terms of setting up our system, we've got an x equation. Something's going to equal 8, the coefficient there, and that would be the ax plus bx. So the coefficient would be a plus b is equal to 8. And then our constant, 4a minus b, that will be equal to 7. There's our system. This one's a nice one to solve by elimination. We'll just add straight down. 5a is equal to 15, so a is going to be equal to 3. And then we can back substitution and find that b is 5 for our answer. 3 over x minus 1 plus 5 over x plus 4. All right, on a graphing utility, we want to graph these and find the approximate points of intersection. Be careful, especially if you're using a graphing calculator on this one. It looks like it kind of disappears. You may need to zoom in a little bit as it goes vertical. Remember, the graphing calculator has a little difficulty looking at anything that goes vertical. So really kind of zero in. There are 2 points of intersection. And to the nearest thousandth, they would be approximately right there. All right, this is lesson 7.5, systems of inequalities. Doing an inequality and then another one. So remember, we're going to graph the boundary line or curve. We're going to decide if it's going to be solid, if it's less than or equal to, greater than or equal to, or a dashed or dotted for strictly less than, strictly greater than. We're going to shade one side or the other, possibly by testing a point on one side of the boundary curve. And we can use a graphing calculator to do some of that. So let's take a look at this. Y is greater than negative 10 over x squared plus x plus 4. We're going to see how we could possibly do that on a graphing calculator. All right, so we're going to go ahead and press y equals, and we're going to enter our function, which was negative 10 divided by. Now, your calculator, it might have the horizontal fraction bar, so no problems. But with mine, I have to put parentheses here to say divide by the quantity x squared plus x plus 4. And then we're going to go ahead and, well, before we graph this, we're going to go over to the left. Over here, we're going to hit enter, choose some other options. So right now it says I'm going to graph this as a line. Yours might show up as a colored line or something like that. That's fine. But if we hit enter, it says I can make it thicker, or maybe for you a different color. And then here it says I can shade above. Now our inequality is y is greater than, so that would mean shade above. That's the one that we want. So if we press graph, it'll show that shading. So it looks something like this, where it shows that shading. Now the one thing it doesn't show, if we're going to try to communicate that, is the dotted part to the boundary curve, because it isn't or equal to, so we would want to show that as dotted. All right, how about using a graphing utility to graph this inequality? All right, so the challenge, now on Desmos, a lot of times you can go ahead and input it just like that, but on a graphing calculator, remember it says y equals, so we need to go ahead and solve this for y. So the first thing I thought of, let's see if we can kind of fraction bus this. Let's multiply everything by the LCD of 16. Then we could subtract the 4x squared. And then we can square root it. Remember the plus or minus, and then we can subtract the 2. So we've got two equations that we're going to input here. Y equals negative 2 plus the square root. Y equals negative 2 minus the square root. And then the challenge would be, how are we going to do the shading? So if we kind of think about this, what exactly is this? Let's see what the graphing calculator shows. So number 1 is going to be y is greater than or equal to, as we kind of pretended it was equals for a little bit while. And then number 2 is going to be less than or equal to. And we're going to see y in a... Let's go ahead. Now we can't put it in as equals, but it is with the inequalities initially. We'll put them in as equals. We'll see what it looks like, and then we can decide how we're going to do the shading. All right, so I have my functions inputted. And right now they're not inequalities because I want to take a look at what the graph looks like. Graph. All right, so once again, remember, as it goes vertical, it really has a tough time with that. So these would connect and it forms the shape of an ellipse. So the next thing would be, where are we going to do the shading? We might want to go back ourselves and take a look at the function and test a region. So our boundary curve is the ellipse. We can pick a point like the origin, test it out in the original inequality. Substitute in 0 for x and for y. Does it make it true? It does not make it true. We would get 1/4 is greater than or equal to 1. That's not true. So we're not going to shade inside, we're going to shade outside. Which means if we're shading outside, we're shading above the first inequality, because that was this one, and below the second one. So when we go back into y equals, so we arrow over, we want to go above the first one, that's that one, drop down, and below the second one. We can see part of it here, but it only does it right there. It really strictly sticks to that above the first one and below the second one. This area here also shaded, though, because it's outside of our boundary curve, the ellipse. And we're going to finish with an application problem that's going to lead into our next lesson. Jimmy inherits $10,000. He plans to invest some, and really what it means there are some or all of his inheritance. He wants to invest at least $1,000 in each of bonds and mutual funds. And he wants to invest at least twice as much in bonds as mutual funds. So if we define some variables, now in a normal word problem we might want to use something like B and M or something like that, but if we're going to be graphing these, and we are, we probably want to stick to X and Y as it then connects to our coordinates and our axes. So let's have X be the amount that he's going to invest in bonds, and Y is the amount that he's going to invest in mutual funds. Okay, so he's going to invest some or all of his inheritance. He doesn't have to invest it all. So we've got X plus Y is less than or equal to 10,000. He wants to invest at least 1,000 in bonds and at least 1,000 in mutual funds. And then he also wants to invest at least twice as much in bonds as mutual funds. So X has to be greater than or equal to 2Y. Let's look at what that would look like in terms of a graph. Probably want some graph paper here. So we've got our system of inequalities, and we've got our scale so that each box represents $1,000. And we've got our first one, and there's multiple ways of graphing that, but the cover-up method or finding intercepts is probably the easiest way. We substitute in 0 for x. The y-intercept is 10,000. Do the same for y. The x-intercept is 10,000. There's our boundary line. It is solid. And if we picked a point, like the origin, 0, 0, plugged it in, it's true. We're going to shade below on that one. And we may want to save the shading for the end, or we can do it right now fairly lightly. We've got x is greater than or equal to 1,000, so a vertical line greater than shade to the right. So vertical line, shade right, a little bit darker. Horizontal line, shade above. A little bit darker. And then this one's a little bit tricky because that's not the way that our functions or equations are usually written. We may want to get y by itself. And y would be 1/2 x, so up 1, right 2 in terms of slope. Or in this case, up 1,000, right 2,000. And then as far as determining where to shade, that's a little bit tricky as well. Maybe we pick a point, something like here, 2,000, 0 is 2,000 greater than or equal to 0. It is, so we want to shade on this side. And there is our quadruple shaded region. And that represents all of the solutions to our system, all the places where Jimmy might be putting his money. That's it for today. I'll see you next time.